Okay, so we'll get started now. So today the agenda is to let you guys know the focusing on the third. So we will first start with announcing some announcements we noticed from the first two MPs and some facts during office hour from lab usement. Then we will introduce to you the project timeline. People in the back, you can hear me, right? Okay, cool. So we'll introduce you to the project timeline and let you know what the three-track project goal will be. So since you already see the gym car and F110's car, I will primarily be focusing on the third simulation track, which is the grades track. And the last, we will open for some question and answer. Okay, so first we will announce something. So firstly, from the experience of office hour demo with the first two MP, I think it's very important to emphasize the importance of reading the documents carefully. So I have answered many times over email, office hour, and campus-wide posts that someone telling me ROS does not work on lab computer, so we cannot even do anything. And I do not have sudo access, anything like that. But in fact, the solution is just one line in the documentation. You need to source a bash file to enable the ROS call, everything ROS related. We also see some groups during the MP1 demo that are not aware of the force ROS back, but that's also part of the MP documentation that you need to download and tune the parameters for the force ROS back. So we also want you to be aware of this. You need to read the documentation more carefully. And also we want to emphasize, you probably need to check campus-wide. Campus-wide is the platform we use to communicate, to announce important decisions. So you probably need to check the campus-wide more frequently, since we see some repeated question being asked on office hour and campus-wide. So if you check your campus-wide post before coming to office hour, asking question again, that might save you some time and you can more efficiently working on your MPs. We also have some questions regarding office hour. So we will suggest you to start work early and do not wait until the last week. As you probably see, the last week the lab is pretty full, but we check with all the TAs for the first 2 weeks of MP0, MP1, there are basically no one in the lab and the TA are free to do their own stuff. So that's we want to emphasize to you in the future MPs and projects, you should start work early and distribute work evenly across 2-3 weeks, not just focusing on the last couple of days to work. So this Friday, we do not have MP related discussions. We will use this Friday as open office hour. So you can please come and prepare with your exam question, MP2 questions, homework 2 questions to come to the lab. So we will discuss. Since this week, we basically have each tier will have 2 hours of office hour. So please utilize this time better and do not wait until last week to last minute to finish MP2. We also have some questions regarding the ECEB, the lab 5072. So one important notice from engineering IT is that do not attempt to modify the global settings. So you already see some computers are broken, cannot be used. After we dig deep into that, the reason is that the NVIDIA driver is not the NVIDIA driver we have default configure for you. So there are 2 different NVIDIA drivers, and that's multiple cases of this happening. So do not attempt to adjust things globally. And this also applies to if you want to go for the gym project or the F110's project. Because everyone is sharing one SSD, there are some ways to recover, but will cost you working times to recover the changes you made. So if you do something globally on F110s on the gym vehicle, it will mess up other team setting, and it will take us more time to recover from what you do. And the same thing is happening in lab. So do not install global package. Do not for example, install another NVIDIA drivers, things like that. That will break the system. And also, yeah.
So what is okay to install locally without touching the global packages? Can you say something about that?
Sure. So anything you do with Python 3-m pip install, that is fine. Because Python 3 pip install is installing on your personal workspace. This is local package to install. But do not do something like apt install, sudo something install, sudo change some sudo access. that's something that will mess up the system and prohibit others from working on the lab computer stream card as well. Are we okay with that? And also, if you have a non-working computer, please report to us immediately. Well, we usually when we ask engineering IT to work on that, they usually respond within 12 hours during the workday and can get the computer fixed. So if you have non-working computers, please let us know immediately and we will work on that, okay? Last point is we also have some questions on tutorial to familiarize yourself with Python and ROS and Ubuntu, Linux. So basically in this class, we are not requiring you have advanced knowledge about Linux. We do not require you to know many Linux commands, bash commands. But you should have a general understanding of what directory is, what file system is, what disk is in Linux system. And there are many online Python, ROS, Linux tutorials. We suggest you go through them yourself, because seeing later on in the project, you will also see many things are heavily dependent on the Linux. We are not using complicated commands again, but you should have a basic understanding of Linux, okay? Are we good on this slide? Questions? Okay, there are also some timelines about the homework and MP we want to remind to you. So by tonight, we will release the TAs are working very hard to get your MP0, MP1 graded. And by tonight, we will give you feedback, grades, and feedback on those homework assignments. And if you have a grade request, you can submit on the campus-wide with a private post visible to TAs and instructors only. We will provide feedback to your regrade request after 1 week after the regrade request due, okay? And I hope everyone is aware of the exam we will be having next week. So it will be exactly this time, this location next week, this time, this location. And for the coverage details, cheat sheet details, we already released on campus-wide. So please check that post for details. And also you also want to be aware of there's a homework 2, MP2 due in the next week as well. So like I said, you should plan ahead and utilize this week to work on that as well, because MP2 homework 2 will also be covered during the midterm. So getting ahead of during the assignment early will help you with the midterm as well. Hello? Oh, maybe the orientation. Okay. Okay. And also we want to let you know that although all 3 previous MP has 3 weeks, homework 3, MP3 only has 2 weeks, because we want you to have enough time to work on project. So again, you need to plan ahead, plan accordingly. Don't wait until the last 2 days of the deadline, before the deadline. It will already be packed in the lab, as you see. But this morning, I go to the lab, work there for an hour. There's no one there. So you should also be aware of starting early and plan ahead, okay? We will talk about the project timeline in the next slide. But any question about homework, exam? Okay, we'll move on. So we know everyone are very excited for a project. So this is the tentative timeline we have for you. So by next week, we will release a Google form so that you can sign off indicating who you want to work with and which track you want to work with, okay? So you can choose different team members from your current MP teams, and you can just sign up. If you don't sign up, we will assign you a team, similar to how we form the MP groups. And it can be from 2 to 4 people, so we'll give you more manpower to work together, collaborate together for the final project. About a week after we release the Google form, we will announce the finalized team assignments. And for the teams who choose to go through the hardware projects, we will start with the safety training for you guys. And note the date of October 24th and 26th. Those 2 lectures, you will do a pitch presentation. So basically tell us your project proposal and what you want to do. What's your proposed method? What preliminary results or experiments have you already do? We will also release a template guideline and a rubric as how to grade those. Note those will count as 10% of your project grades. On November 10th, this is a Friday, during the lab sections, you will need to sign up like 15-minute slots. Each group needs to sign up for a 15-minute time slots to discuss your progress with TA. We will give out some example of what you can demo like later on. And also note November 13th, December 5th, those 2 lectures will be allocated for the final presentation. So the final presentation will count for 30% of your final project grade. And we also require you to write formal final reports and upload the videos of your projects. They will together account for 50% of your project, and that's due at a later date. So you still have like a week after the final project to still work on your project. We will release all the details later, and these slides will also be available on the course website like later today. Do we have questions on this timeline? Okay, I will move on. So next, I will going to talk about the we see there are 3 tracks. I will talk about the details, like high-level language of what you should accomplish in those 3 projects. So you already see like how I introduced you to this F110, right? It has camera in front of it. It has a 2D LiDAR that can scan like 360 degrees. It also has a Vicon system, although the Vicon board is not shown here. Basically, it's like an indoor GPS, which can give you very accurate localization information. And your output control is Atman control, which is target speed and steering. Many of you should already see this in MP2. So this is one of the way we use MP to prepare you for the final project.
So, Zoom video window. We can be visible.
So, and the goal we set for everyone who go for this F110 track is that you should get land detection and land following working. Your F110 camera, the basic goal for everyone who aim for this track is that you should rely on only camera sensors to complete 3 laps of this track. This track is in IRL, a closed building next to ECEB. And you should use some metrics like in MP3 you will see. So we will use something like a particle filter for you to help you localize your vehicle itself with some state estimation with histories as well. So pay attention to the next 2 MPs. It will help you do better in projects. And we also offer some extra credits task if you want to go for this track. It will account for 5% of your total project grades. So there are many options. Here we listed a few. For example, the basic goal we ask everyone to finish is that you only use camera sensors, but you can use LiDAR sensor or Vicon sensors to achieve additional goals. For example, if there's an obstacle in front on the lane, the vehicle should stop. And when the obstacle is removed, the vehicle should resume driving. And also, we will ask you to do speed control over different parts of the track. As you see, there are curved parts, there are straight parts. So we will ask you to come up with an algorithm similar in what you will see in MP2, like how do you decide speed in different part of the track map. But in addition, we want you to pay attention to, we want you to encourage work on the hardware experiments. But we also want you to be aware of some additional efforts you need to make in hardware projects. For example, on the right, you can see, so this is the default setting of what the arena will look like. Like each groups who go for this track will need to rearrange the headings, like according to this picture. And after you leave, you will also need to put the headings back so that other people can use the arena for experiments. And you will also need to go through some safety trainings. You cannot, for this track, you cannot like go to the IRL arena and work anytime you want. You have to, there has to be a graduate TA supervising you for safety reasons. And so that's what we will do is we will release a Google Sheets like 1 week ahead so that each team aiming for this track will sign up using the Google Sheets. And we might impose some rules on how many hours a team can work, depending on the total number of teams and the total number of hours we get. then like you go to the lab to work on those during the specified time slots. There will be a simulator provided to you so you can debug offline without using the hardware. But also note there's a difference between simulator and there's a gap between simulation to reality, which is this hardware. So if you want to go for hardware, we want to encourage you to try as many approaches as possible, but you also should be expected that you might need to spend extra time to have some extra things working, like what we said here. Next, I want to talk about the gym project. So last week during the high-bay visit, you already see, so we have a gym vehicle and it comes with a lot of sensor. So this one has a 3D sensor, which is a 16 channel. So which is more powerful than the LiDAR on the F110s. And it also has GPS, radar, camera. The control is a little bit different here. So instead of specifying a target speed, target velocity, it's asking you to directly control our throttle, brake, and steering. And by the way, we also have some questions on, like, do we need to write the drivers for the hardware ourselves? The answer is no. You do not need to write a low-level drivers yourself. We provide the interface to you so that you can focus more on how you utilize those sensor information at getting control values. So basically, you do not need to worry what torque we applied on the tires, like what power output is the F110s, but you only need to rely on these input and output to work on stuff. Okay. Next, so the goal we want everyone to finish on this project is that similarly to F110s, lane detection and lane following with only camera sensors. But they will be coming with some additional challenges. So as you see in high-bay maps, it's probably not very clear on this map, but during the high-bay visit, you see not all lanes are straight. There are some sharp curvatures. There are some turns, right? So your job is to make sure that your vehicle, gym vehicle, can follow curved lanes, like with some algorithm you come up, state estimation, like prediction, to make sure your lane detection and lane following work on those curvatures as well. Okay. Similarly, we have some example of extra credit opportunities, like if you can safely stop when the obstacle appears, or if there's a stop sign. You probably already see in high-bay facilities there's a stop sign. If stop sign appears, you should stop. When stop sign is removed, you should resume. And also, you could try different speed among curvature. What's the maximum speed you can achieve without going out of lane? Something like that. Again, note if you want to go for the hardware project, there will be some extra time and constraints your hardware project might be. So you should plan accordingly and be expected of those challenges. For example, in the gym vehicle, we cannot go out if it's raining or snowing. And you also need to do similar things, like we will release our time slots, Google Sheets, like 1 week ahead, and you will need to do the reservation. You cannot go to high-bay anytime you want, but you have to work under graduate TA's supervision. Okay. We'll also provide a simulator to you so that you can work offline. When you are not with the gym vehicle, you can try to do something. But you should also be expected that there will be a slightly dynamic difference, environment difference in the simulator and the real gym vehicle. So keep that in mind when you go for that. Any question on those two? Yes.
So in MP1, like the difference between the simulator, or say like the simulation and then like the real camera video, actually made changes to like the infrastructure of certain nodes we could apply to filters. Would that be the same thing here, where the simulator would be like very different from real time, or is the data?
So similar to MP1, your algorithm is the same, right? But something else is different. Image size is different, like channels, RGB, BGR is different. So what I'm trying to say is, yes, algorithm will be the same, but there will be some discrepancies among real environments and simulations.
So like simulation would still be getting like the 16 channel like LiDAR output data.
Yes.
At home.
Yes. But you can assume you should be expected of some difference, right? For example, dynamics will be slightly different, even under different road temperatures. the friction might be different, right? And also in simulation, you almost exactly get the perfect like camera images. But in reality, the sun angles changes, the cloudiness changes, right? So you might not get the perfect like RGB images, like what you will see in the simulation. So that's are the differences I think you should be prepared for. Any other question? Okay, so we will continue to talk about GRACE. In this slide, I will give a high-level introduction about GRACE, and in the next few slides, I will give more technical details. So in this simulation track, what we will give you is the ground truth information about the track. For example, what are target waypoints to follow? Similar to MD2, but with additional constraint, you see there are many other scenarios, many other dynamic and statical obstacles in this scenario that you need to consider. So the goal is that your controller needs to finish 4 tracks with 2 scenarios under specified number of times. We have created 6 maps in total, which we will all release to you, but we will only evaluate on those 4 maps. I will release the benchmark score like later, so you can see what are the detailed time you need to finish. And the extra credit for this track is that you should be able to use camera image alone to navigate instead of using the ground truth of your current location, other vehicles' location, and your target waypoints. And next, I will go into details about how the GRACE project will look like. So GRACE is not only a project for 44, it comes with some context. It's a competition that involves many universities, many groups in the past. We aim to bring together the researchers in AI, robotics, control, and it's a platform for you to have your controllers with different algorithms to handle the dynamic and uncertain environments. We have many submissions over the past, and we also expand that to some outreach activities like engineering open house and summer camps. So many submitted controllers actually becomes a benchmark for testing and verification research that we have done in the past. So this is the detailed architecture of how GRACE works like. For the middle part, you can see this is a simple simulation with no other obstacles in this case. In this case, it's just like 2 controllers racing against each other. And in the GRACE competition, we also have different models, for example, bicycles, Cybertruck, Tesla Cybertruck, Dodge's car, so different type of vehicles. And we have come up with different types of maps with simple maps, complicated maps with different curvatures like that. So how this will work is that we use a simulator called Carla. Carla is a simulator for autonomous vehicle. So we mostly utilize some of the APIs and rewrite the components so that what will happen is all you need to do is writing a controller, the yellow part in this loop. Then we will load all other race configuration, tracks, scenarios, models, and evaluate on your controller using a set of loops. In this project, you do not need to worry about perception because we already provide the ground truth perception values to you. If you want to go for using the perception as input of your controller, that's what you will do in the extra credit. Do you have a question? Yeah.
For the extra credit,
yeah.
One, for instance, for the top spin, all the top scopes away and location, even only perception.
Only perception for all of those. Yeah. So we have slightly higher standard for software project because like you see for the hardware project, you have like some other constraints we talked about before, right? But for software project, the advantage is that you can work in the lab anytime you want. There will not be any like weather constraints, TA constraints. So you can work on the lab and even you want to if you have a Linux system yourself. But it needs a somewhat powerful GPU. So like 1016, 1018 will probably not work. But if you have a 3080, that's more than enough to run a simulation like this, of course. So on a high level, this is a visualization of the input output that we ask you to write. Basically, the input is the blue dots, is the LAN information that you need to follow. And the output you need to decide is your velocity and headings based on those input information. So this is just a visualization for you to understand your input-output interface. It is not the actual simulator. So again, like we will provide you with the LAN boundaries, we'll provide you with the ground truth information about the obstacles, could be a person or vehicle, and then you need to decide your controller logic. Okay. How you decide the controller logic, unlike in MP2, we specified you have to use a per pursuit controller, but in the final project, it's open-ended, up to you to decide any way you want. Okay. And the testing pipeline. So you might already see this from MP0 grading, right? So basically you can see like the testing pipeline, MP0 grading is a simplified version of the testing pipeline we have for grades competition. So on the left-hand side, basically where user would see are only these two websites, the output leaderboard website and the input website where you need to submit the controller file. But in the backend, on the backend, you see many things are happening, right? We are reading your submission. We are launching your simulation in the backend, loading all the race configuration, execute your controller, email you the results, writing to the database, and saving the logs, compiling the videos, the graphs, and then showing on the leaderboard website. So we plan to do similar things for students who go for this track, and so that you can see some cool visualization on public website from you. And here I attach expected controller behavior of what your controller should look like if you go for this track. Let's play it. So the black one is Eagle vehicle, which is controlled by your script, your controller script. And there are other obstacles you see here. The other vehicles, other obstacles are running like using our customized scripts. Your job is to navigate around those obstacles without collision, but still finish those light boxes. The blue boxes are like waypoints you need to reach. So your job is to avoid collision while reaching all those the boxes within specified number of time, similar to like a racing game you might see. Okay, any question? Okay. Let me play this again so you can see it's navigates around obstacles, reaching waypoints. And this one is using the ground truth values, by the way. It's not the extra credit, just using vision for everything. So to try to help you better, we also divide our staff team into 3 subgroups. Although all of us know the basic of how F110s, how GYM, how Grace operates, but we divide into 3 subgroups so that we can work more efficiently with you. So if you want to go for the GYM project, the first point contact should be Hongyi and John. You probably already see them during discussion and the habit visits as well. If you want to go for the F110s project, your first point of contact should be Yeji and Summit. And if you want to work on the Grace project, your first point of contact should be me, okay? Although everyone, you can approach any TAs for like quick catch up, but those are people who knows about the details, most details of those project tracks. So we also want to take a quick poll right now. It doesn't have to be like final, but if you want to go for the F110s project, could you raise your hand? F110s project. Okay, so 1, 2, 3, 4, 5, 6, 7 groups. If you want to go for the GYM project, could you raise your hand? Maybe nine groups, approximately. Grace project. 1, 2, 3, 4. Okay, cool. No idea. That concludes my presentation today. Does anyone have some additional questions? If not, we will post the recording and the slides as well on the course website. And if you have any question, you can post on campus wire or go to office hours for additional help. Yeah. Sure.
These extra credit things are more like guidelines at this point. We can provide more ideas, and if you come up with some ideas, that's always welcome.
Sure. Pardon? Yes. Yeah.
So yeah, we will not set up a different track. We are considering finding some space like that, but it seems unlikely. But we can play various games around the track, like obstacles.
Also, one notice for extra credit. So we want to encourage you to make sure your goal is working, like the basic goal is working first before like trying to attempting some additional extra credit. So we see some groups that like in the previous year abandon the goal completely and only shoot for extra credit. That's not something we want to encourage. So you should have your goal like completely working. Or mostly like 90% working before you attempting to do the extra credits. Okay. The lights of the car. Yes, it's controllable. It's controllable through scripts. It's actually quite easy. So similar to what we asked you to do figure out in MP2, you will need to figure out an additional type of lost message. Like then there's a very simple variable you can see how to generate something. But usually during the day you don't need that, right? Yeah. That's all. We also plan to use most of the daytime for experiments. Late nights might not be safe. Yeah.
There was a project a few years back. It's a bit different from these projects where the students rigged up a microphone with the gem car, and they wanted to detect if there are emergency vehicles around, then the car would turn on the blinkers. So this was the time there was some news about Teslas crashing into emergency vehicles, so that was the motivation. Cool project, but not so much about control, but more about this type of thing, fiddling with the canvas. Pretty cool. Questions about logistics? How many of you think you have a project team that you already know? Okay. Maybe I should ask the other question then. How many of you are going to change your team or actively looking for a project team? Okay, so look at each other. Maybe you should talk after class or send some notes on campus file. It's a good time to finalize the team. Okay? Not having a happy team is a recipe for the project not working out well.
Yes. Oh, also one notice I forgot to mention is whoever works at the Taipei team, like you need to make sure at least one of you have a valid driver license. Yeah. And it's recommended you have a transportation there so that it's convenient for you to travel to Taipei.
All right, so we have a bit of time, so we'll do a little review.